Hi, dear students, how are you? I hope you're fine. Welcome to quarter 4. Today we're going to talk about what? Today we're going to talk about circles. Circles, guys, we have here some vocab that we have to know. We are going to talk about lines that intersect circles. So we have two important questions that we have to know. How do you identify tangents, secants, and chords? How do you use properties of tangents to solve problems? So the interior of a circle is the set of all points inside the circle. And what about the exterior? The exterior of a circle or the set of all points outside, of course, the circle. So let's start here. Don't panic. We have here circle. We have here some lines and segments that intersect circles. As you see, I have here one. I have here first of all the chord. This is the chord. The chord here AB is a segment whose end points here lie on the circle. So the chord here we got here a segment that it has here end points, okay, inside or it's on exactly on the circle. Okay, so this is the chord. What about the secant? The secant is a line. It's not a segment. It's a line with two arrows here that intersect the circle at 2 points. Okay, here they intersect the circle on 2 here at 2 points. So this is called the secant. What about the tangent? The tangent here is a line that has what? This is a line in the same plane or here as a circle that intersects here it at exactly 1 point. So this here tangent, it intersects the circle at exactly 1 point. This point is very important. This is the point of tangency. This exactly point is the point of tangency. So the point where the tangent and the circle intersect is called the point of tangency. Okay, this is very important to study. We have got here the question comes like this. Identify each line or segment that intersects circle L. So if I ask you about the chords, what about the chords here? What here can you say about the chord? I have here J, M. This is a chord. This J, from this point J, M, this is a chord. K, M, this K, M, it's also chord. Where's the secant here? Line. Okay, remember well. We have here JM. This is a segment. From this point to this point, this is a segment. But if I take the R with me, so this is the line JM, and this is now the secant. And what about the tangent? Where's the line of the tangent here line? It's M. Here it's M, and it intersects here the circle at exactly 1 point, which is H. I have, where's the diameter here? The diameter is very easy. It's K, it's KM. KM what segment? Because it here has in its center L. Where is here the radii? Where are the radii? We have here more than one radius. Here radii is the plural of radius. I have here KL. As you see, this is KL and LM. And I've got here L, what else? LJ. Can you see LJ? Segment. Okay. Okay. Then we have another terms that they are very important here. Remember, my dear students, here we have congruent circles. Congruent means that they are the same. So two circles are congruent when they have the same or congruent radii. So if they have the same or congruent radii, so they are what? So they are congruent circles. Circle A is congruent to circle B, and this is if AC chord is what? Radius is here what? Is congruent to radius BD. and vice versa. So I can say AC segment is congruent to segment BD or radius BD if the two circles are congruent. I've got here another thing to remember, the concentric center. What's this concentric circles? The concentric circles here are what? Are coplanar circles with the same center. So remember, the concentric circles, they are circles that have the same what? The same here center. So this is called concentric circles. What about here the two circles that intersect at what? At exactly one point. So we have here two circles that intersect here on exactly one point here. Can you see this? This one. So they are tangent circles. They can be internally tangent circles, and we can have externally, like this, externally, I want to show you, externally tangent circles. So they meet here at one point, this point. Okay, guys, and this is what concentric, don't forget. Okay, after that, let's have some problems to see how can we solve those problems. Find the length of each radius, identify the point of tangency, and write the equation of the tangent line at this point. So first of all, I have got what? Find the length of each, okay, find the length of each radius. So radius of circle R. Okay, guys, radius of circle R. Can you see circle R? Where's the radius here? I've got here, this is the radius. Okay, I will count here how many units I got, 1 and 2. So the radius here is what? The radius here is 2. Okay, guys, the radius here is 2 because I counted here from the center 1, 2. And here for the other side, -1 and -2. Okay, so the distance here between the 2 points is what? Is 2. Easy? Easy. What about here circle S? Let's count together on the coordinate plane. Here S is what? Is 1.5. This is 1.5. So I've got here 1.5. Okay, so point here on is point S here, the center is on what? 1.5 from the center. 1.5 from the center. So we got here 1.5. After that, he asks me about what? He asks me about identify the point of tangency. Where's the point of tangency here, guys? The point of the tangency where the two circles what? Meet or intersect in the best word. So they intersect here on what? On this point. Can you see this? Yeah. This is what? This is, I have on x-axis, I move on x-axis first. I have here -1, then -2. So this is what? This is -2. -2, do I move here up or down? No. So -2 and 0. This point -2 and 0. So point here where the point S and the tangent line intersect is -2 and 0. This is the point of tangency. Okay, guys, the equation of tangent line is what? Let's focus together. And the equation of tangent line here, y equal what? We said here, this -2 and 0. So y equal what? Y equal 0. Let's have another kind of questions after this theorem. A common tangent. Guys, I have here a common tangent is what? This is very important too. Is a line that is tangent to the two circles. So I got here, can you see line L? This is what? This is a common tangent because here it intersects here circle A and circle B because it intersects here circle A and circle B. So I have here a common tangent which is L, and I have another common tangent which is M. Here it intersects here circle B and also circle A. So here lines L and M are common external here because from outside to circle A and B. I have here common tangent that is internal. How? Because we have here, if I say here line Q. Line Q here is what? Is a common tangent. It here intersects circle B and what at this point, and also circle what? Circle A at this point. And I have got here another line which is a common tangent, external common tangent, which is here line P. It intersects here circle A at this point and circle B at this point, this one. We have here this theorem. This is very important one and very easy one. If a line here, if a line is tangent to a circle, if I say this line is a tangent to a circle, okay, then I conclude what? I conclude that it's perpendicular to the radius drawn to the point. So it's perpendicular to the radius here drawn to the point of tangency. So the line here tangent to the circle, the center here, line here is perpendicular to the radius. Okay, guys, and vice versa. So L here is perpendicular to L here. This L, this line L, the line of tangency is what is perpendicular to the radius, which is here AB, the radius AB. I have here vice versa. I have here if a line is perpendicular to the if here the radius here is perpendicular to a line outside the circle, and very important that it intersects at a point, and this is very important, and it intersects the circle at one point. So I've got here what? Perpendicular. I've got here what? Perpendicular. I've got here what? I've got here this line is called now what? A tangent to circle C. Okay. Now we have another theorem. If two segments here, okay guys, if two segments are tangent to a circle from the same external point, so AB and AC, we have here two segments as you see. They meet or intersect at a point, and here they intersect here the circle, okay, then the segments are congruent. The segments are congruent to each other. If two segments are tangent, to a circle from the same here external point, so they are what? They are congruent, okay? So AB now is congruent to AC, okay? Let's have a question about this. I have here what? H and HK segment. Let's see this together. HK segment, this one, and HG are what? Are tangent to here circle F. Okay, guys. So what do you think? Find HG. Very easy, because what? Because they are equal, because they are congruent. Why? Because they have here two tangents, they intersect at exactly external points, so they are equal. So I'm going to find what? To find the by using what? By using here my equations. For a 4 plus 2a equal 5a minus 32, because it's given in expressions. It's very easy now to do it. 3a minus 2a equal 4, then 3a equal 36, then a equal 12. Okay, guys. So HG now, I'll substitute a for 12. 4 plus 2 times 12. So it will be 28. I think this is very easy lesson. Please study well. And if you have any questions, please send me. Thank you. Bye.